This is part of craft project funded by National Science Foundation, and today we are collaborating with Permafrost Discover Gateway. And the topic of today's conversation is infrastructure mapping with AI. Okay, next slide. Okay, next slide. A little bit more information about our project for those who just joined us the first time today. It's a research coordination network that was built based on collaboration between several initiatives, including navigating new Arctic Community Office Convergence Working Group on Infrastructure Futures and existing for already decades RATIC initiative, which stands for Rapid Arctic Transitions Due to Infrastructure and Climate Change. And for this project, we started to work together with Ratsararmiut Native Council and Native Village of Mekoryuk to think together about how we can develop Arctic infrastructure futures that would be more relevant for community needs. And we have multiple colleagues from diverse universities, and we are aiming to have as many perspectives as possible using this network. So next slide. So it's already fifth webinar in this project, and we have scheduled them every first Monday of the month. So today you will hear from our colleagues Wenwen, Bessie, Weston, Chandi, Witharana, and Elias Manos, but you are welcome also to join us for next meetings that are scheduled every month. So yeah, stay tuned. And then I'm giving the floor to Wenwen, who will be moderating this webinar.
Thank you, Vera. Next slide, please. Yeah, because today's webinar is co-hosted by CRAFT, our RCM project, and the Permafrost Discovery Gateway. So I just give a little bit introduction about this project. Permafrost Discovery Gateway is a NSF-funded project, and later we receive a 5 million research grant from Google.org. So the goal is to use geospatial AI to track permafrost soil in near real time, so we can have a better understanding on the changing Arctic landscape to inform climate actions. And this project is led by Dr. Anna Liujidao from Woodwell Climate Research Center, and it is a collaboration among 8 international organizations. Next slide. Yeah, so today's webinar, we will have experts from both of the projects where we are going to discuss when AI meets Arctic community and how we can use AI to enable infrastructure mapping at the pan-Arctic scale to support the Arctic communities related to resilient planning and also disaster response. And this is the outline of today's webinar. First, I will give a little bit of introduction to our panelists, and then followed by the presentations. And we will also have some time for question and answering at the end. Next slide. Yeah, so these are the panel discussion questions. So how we are going to give it today is we will first invite our panelists to discuss their own work, or if they choose to answer or put their discussion around one of these questions in terms of how they are seeing remote sensing and AI could support the Arctic infrastructure mapping and what are the limitations of these technologies. And also from the community perspectives, what are the biggest challenges in terms of infrastructure planning and also data access? And in the future, how we can foster effective collaborations between researchers who develop AI tools and also the communities who will benefit from these new technologies. And also, I think a very important discussion point is how can we build trust around these AI solutions. When we made the decision makings, especially high stake decision makings, how we can ensure that our AI solutions are trustworthy and also transparent. Next slide, please. Yeah, we will have three distinguished panelists today. Ms. Bessie Weston is an Indigenous Alaska native of Cubik descent and was raised in the Bering Sea in Nunivak Island. And Bessie currently serves as a co-PI and also on the advisory board for NSF-NA project. Her background includes visioning, planning, and implementing rural environment and small-scale infrastructure improvement. Next slide. And we also have the pleasure to have Dr. Chandi with Rana as our another panelist. Chandi is assistant professor of remote sensing in the Department of Natural Resources and Environment at the University of Connecticut. Chandi is also a co-PI for the Permafrost Discovery Project. His research focuses on AI-driven methodological advancements and adaptation to enhance the efficiency and accuracy of large-scale analysis of high-resolution remote sensing data across multiple application domains. And our third panelist is Elias Manos, who's a PhD student also at University of Connecticut. Elias was actually a PhD student of Chandi, and he's also a part of the Permafrost Discovery Gateway project. Elias is broadly interested in using Earth observation for disaster risk management and also monitoring human exposure to hazards. He recently have developed an AI approach for the infrastructure mapping near the Arctic communities. I think he will introduce his work, very interesting work today. Next slide. And I'm the moderator of today's webinar. I'm a part of the craft and also a co-PI of the Permafrost Discovery Project. My name is Wenwen. I'm the professor in the School of Geographical Sciences and Urban Planning at ASU. And my research focuses on cyber infrastructure, big data, and geo AI. And I have always been interested in applying this advanced technology to help solve Arctic problems. Next slide. So just to show you a few of my research, which has been focusing on building the cyber knowledge infrastructure to make the data more discoverable, searchable, more seamless integration with each other, and support the real-time visualization of geospatial big data, as well as the intelligent analysis of this data. And the GeoAI serves as the intelligence core that power up the entire data to knowledge production pipeline. Next slide. So in the past few years, my team has developed several cyber infrastructure solutions like Polar Hub, which is a large-scale web crawler to discover the distributed geospatial data covering the polar regions and also globally. Currently, it has found almost 200,000 of distributed geospatial data set from over 150 countries. So this really helped to increase the accessibility of polar data to support different environmental and climate research. If you are interested, you can go on to this live link to access Polar Hub. Next slide, please. And we have also built big data visualization tools like Polar Globe, which allows us to view the polar climate data from different angles. For example, we can view the volume rendering. Like we can view the temperature data for Greenland at the different seasons, so we can observe the different weather patterns. And we can also support the vector field visualization, so we can allow the weather watchers to look at what is happening in the Earth's atmosphere now. So a lot of these tropical cyclones or cyclones in the polar regions can all be captured through this real-time big data visualization. And we can also allow the vertical profile visualization, like if you draw any trajectory on the Earth's surface, you are going to view how the vertical profile of temperature and other atmospheric variables looks like along your area of interest. Yeah, so these are the cyber infrastructure tools that we have developed, and in recent years, I have been dedicating in applying AI to support the Arctic research, like monitoring permafrost thaw. And what we haven't done is to use AI for doing infrastructure mapping. So I really look forward to hearing what our colleagues would say about AI for infrastructure mapping in the Arctic. And next, we will welcome Chandi to discuss his research.
Well, thank you, Wenwen. Thanks for the introduction and staging everything. So I'll quickly go through my slides because mine and Elias are well interconnected. So I will give the broader picture what we are doing. So just to entice the audience, we all know permafrost is degrading, impacting coastal infrastructure as well as inland infrastructure. At the same time, reshaping some of the natural processes like hydrological flow and vertical settlements, vegetation patterns. So the changes are across the board and both natural and impacting both natural and human environment. So the next question is that how we monitor these changes happening at a large scale, not only Alaska, but Canada and Russia as well. So if you could go to next slide, please. Right, so yes, Arctic is changing rapidly, and the intriguing question is how we monitor this large landmass. Because traditional methods, they are precise, accurate, nothing wrong with that, but it's just a matter of how we scale, how we run these things at scale, what data and tools available, especially for this infrastructure risk. Next one, please. So now the organic solution would be remote sensing, right? So we have different sensing platforms from moderate resolution satellites, Landsat Sentinel 30-meter, 10-meter resolutions to some sporadic aerial missions, not pan-Arctic coverage, but we have good amount of pan-Alaska coverage. And so they come with different pros and cons. It could be the spatial resolution or the temporal frequency and the area covered from a single scene. So if you want to study certain things happening at the individual object level, right? It could be individual infrastructure type or building or the road, runaway, right? So we need to get down to sub-meter resolution. And at the same time, we need to scale up to the entire domain, looking at individual objects, but map everything at the pan-Arctic scale without compromising spatial details as well as the geographical extent. That's a place where commercial satellites come very handy, right? So they can cover the entire landscape and get down to 30 centimeter resolution in theory. So we can see individual human built infrastructure in these images and we can create really accurate maps. So next one, please. So the animation you see on your left is commercial satellite images coverage since 2000. We first launched the commercial satellite in 1999. Since then, we have been imaging the entire Earth, including 60 North. So in the early days, right, 2000s, we didn't have much coverage. But if you look at the animation or the graph on your right, you will see enormous amount of these commercial satellite images available across the Arctic. So literally we can get down to 50 centimeter or 30 centimeter resolution based on this commercial satellite image archive. So a lot of data, right? More than 3 petabytes of data, 10 million image scenes. Should be more than that. So So how do we analyze this data? Next slide, please. Right. So we have the data, and the data is in the right resolution, and we can do the extraction without compromising spatial details and geographical extent. To get data into science-ready products like infrastructure maps, we need AI algorithms, and to run algorithms, we need a good amount of computing resources. Once everything is set, after the equation sign, we have a lot of data, and then make them discoverable to the user community through Permafrost Discovery Gateway. Next one, please. All right, so the previous slide, you had two question marks, and these are the answers we created, right? So we push huge amount of data into supercomputing clusters and do pre-processing, then bring in the AI analysis, which will be explained in detail, Elias. So just take the word AI analysis, then do the post-processing. Everything happens in supercomputing clusters. Create large scale maps, but still finer resolution, the resolution we never had before. I think that's all I have. I will pass to Elias. Thank you.
Yeah, thank you, Chandi and Wenwen. So today I'm just going to be kind of sharing some results of our infrastructure mapping research, particularly our results from mapping buildings. There's a number of different kinds of infrastructure that we have mapped, but this will focus on buildings in particular. So this is kind of an overview of the AI analysis pipeline that we used in this research. So these are some technical details, but I'm going to talk about it anyway because people might be interested in this. And so we adopted an out-of-the-box machine learning architecture that's comprised of an encoder and a decoder. And actually, this particular configuration, using the ResNet50 encoder and a UNet++ decoder, this is actually one of the most popular architectures for image analysis in recent years, including in remote sensing and everyday image analysis, and spanning the running the gamut of applications. And so we manually digitized buildings in thousands of image chips that were split from about 20 Maxar satellite image scenes of communities across Arctic Russia, Canada, and Alaska. And so then we trained the decoder of the architecture to detect buildings and roads. So two kinds of infrastructure. Then we applied the model to Maxar satellite images of approximately 1,000 communities across the Pan-Arctic region. And we ran this on a supercomputer called Lone Star 6, which is managed by the Texas Advanced Computing Center. It's also an NSF resource. Next slide, please. And so here is some results of this model. We trained the model, then we tested it on some samples. And so this is the result of that. Here's some of those predictions on various image chips. And this is spanning Russia, Alaska, Canada. So you can see that there's a mix of, I know that top left example right there is Norilsk, Russia. And then the third image, top row is Prudhoe Bay, and so on. I think some smaller villages in Canada are in there. But so this is what this ends up looking like. Next slide, please. Okay, so here is basically the summary on the Pan-Arctic scale of the buildings that we mapped. And so it's in the map, it's a little bit difficult to see because the mapping is fine scale, but it's also done on a Pan-Arctic extent. So I had to summarize our map at a very fine scale. But so you can see that in this table here on the left, in Alaska, we mapped about 53 million square meters of buildings. Canada, we mapped 10 million square meters. Russia, we mapped 157 million square meters for a total of 221 million square meters in terms of the building area. And the total count is over 1 million buildings. Next slide, please. And so this is right in an attempt to establish a geographically comprehensive Pan-Arctic building inventory. We actually merged those results you saw in the last slide with OpenStreetMap. Now, some people may be familiar with that, some people may not be, but OpenStreetMap is actually one of the best available sources of globally harmonized high-resolution infrastructure data, particularly for buildings. And OpenStreetMap has actually been used in some recent Pan-Arctic scale studies that tried to assess the exposure of Arctic infrastructure to permafrost thaw, and also even to estimate economic losses caused by infrastructure damages due to permafrost thaw. And so after merging these two data sets, we're able to kind of see what gaps actually exist in OpenStreetMap. And so what we did when we merged the two data sets is we basically gave priority to OpenStreetMap. So if there's two building footprints that overlapped from our deep learning map, which is called Habitat, by the way, that's how we coined it. Habitat, if two building footprints overlapped, the building footprint from OpenStreetMap gets the priority. That's the strategy we deployed there. And so you can see that we can find that the percentage of newly mapped buildings across Alaska, Russia, and Canada. So in Alaska, if we merge OpenStreetMap and our deep learning map, you can see that 45% of that building area comes from our deep learning model. In Russia, 23% of the building area comes from our model, and in Canada, 13%. So you can think of this as this is the percentage of newly mapped buildings that don't exist in OpenStreetMap. And OpenStreetMap, again, this is the data that has been used in recent years to understand permafrost thaw risk. Next slide, please. So this is kind of getting even more into detail here. This is the number of newly mapped, the area of newly mapped buildings by region. And you can see these are bar graphs for Alaska, Canada, Russia. And interestingly enough, in the Sakha Republic in Russia, we mapped 20 million square meters worth of buildings that didn't exist in OpenStreetMap. 10 million in Khanty-Mansi, and then Alaska, I think it's 8 million, and then Yamalo and Nanet's 4 million, and so on. So obviously it kind of makes sense that in Russia we mapped the largest amount of new buildings, just because obviously Russia has a lot more infrastructure compared to Alaska and Canada. But this is, to me, this is very it's interesting, and it kind of affirms some of the assumptions or suspicions that past researchers have had. If you look at some of the past infrastructure risk assessments, the authors of these studies have had suspicions that Russia has some pretty big data gaps in terms of infrastructure. So this only affirms that, and it kind of puts a number to it. And so next slide, please. And so these are just the maps. On the left-hand side, this is the map of the new building area that we mapped as a percentage of the OpenStreetMap area. So what's the percentage of the new contribution that we have made? And you can see that obviously it looks like in Russia, you can see that that percentage is pretty high. And then on the right-hand side, this is the total merged building area made up by our deep learning map and OpenStreetMap. So this is kind of our attempt at kind of a baseline, geographically comprehensive Pan-Arctic scale building inventory. Next slide, please. Okay, so this is kind of more the fun part. Now you can see what this actually looks like. So I made a map particularly for across Russia, some of the different regions with the highest data gaps that we filled. And so you can see that the red polygons are building footprints from OpenStreetMap. The green come from Habitat, so that's our model and our map. And so this is just a visual representation of what those data gaps look like. You can see there's a lot more green, right? And those building footprints didn't exist before until we applied our deep learning model on Maxar satellite imagery. Now, there might be those maps may exist somewhere. There may be some government organizations may have these maps, but they're not really, obviously they're not accessible if past researchers haven't been able to resolve those areas, right? So that data may exist somewhere, but it's not openly accessible, and that's kind of the point of our work here, is to make a centralized, accessible Pan-Arctic scale building inventory that's geographically comprehensive. Next slide, please. And I've passed 10 minutes here, but as it's important with any kind of AI, artificial intelligence talk, this is an accuracy assessment. So we measured the quality of our deep learning results against some authoritative manually drawn building maps provided by governments, particularly the North Slope Bureau and the government of Nunavut from Canada. And so by spatially overlaying the predicted footprints and the reference footprints, we were able to quantify their agreement with several different metrics. And I'll quickly just go over this. So in the top row here, you can see Hausdorff distance and turning function distance. These basically they measure how far off the geometry of the boundaries are from each other. So the lower the score, the better. IOU, intersection over union, measures the degree of spatial overlap between any two given footprints. And then the bottom row, precision, is a measure of the area of detected building footprints that exist in the reference data set. So in other words, how correct your map is. Recall is a measure of the area of reference building footprints that were successfully detected. So in other words, how complete your map is. And then F1 score is just an average of these two. And so with an F1 score around 0.80, right, and this metric scales from 0 to 1, we can say that the detected building footprints, our map has a fairly high accuracy. And I should note that because our deep learning map and the manually drawn maps provided by different government sources, they come from imagery that was registered geographically. It was geographically registered differently. So there's kind of a mismatch between the two. And we tried to align them, but it's impossible to get a perfect match. So these numbers are a little bit harsh. They're a little bit strict in terms of what the accuracy really is. And I'll finish up here. Next slide, please. Again, so this is just some visualizations of what this looks like. These are cases of where we have a good intersection and a good boundary agreement. So the green is from our map, and the orange is from kind of the reference data set. Next slide. And then this is kind of examples of where we have good overlap, but there's some disagreements in the boundary. So maybe not, some people might say that's important. Some might say it's not important. It depends. Next slide, please. And these are some examples of kind of bad predictions. So predicted footprints, they can be incomplete. And as you can see, these are all large buildings. So the model kind of has this ongoing issue with detecting large buildings because sometimes the building itself can exceed the image that gets input to the deep learning model. So the model struggles to learn what an entire building looks like. And so when it's faced with a large building, it'll struggle to map the full extent. Okay, next slide. So this is a video. I don't know if you'll be able to play it real quick. Hopefully it loads. So this is the data is actually available right now on the Permafrost Discovery Gateway, the link on the top of the slide there. And this is me zooming in on Anchorage. So the data is only available for Alaska, not at the Pan-Arctic scale, but you can actually go in and see this, and you can see all the different building footprints and where they came from, if they came from OpenStreetMap or if they came from our deep learning model. And there's roads in there as well. Okay, so next slide, and this is my last slide. Yeah, so this was we kind of synthesized these results. So we took our building and roadmap for Alaska, and we actually conducted a kind of a risk assessment to estimate potential economic losses due to infrastructure damaged by permafrost thaw using our comprehensive map. And we actually, like you saw earlier, the number is slightly different because we did a little bit more mapping work later on. But with our model, we expanded the OpenStreetMap building footprint by 47% across the state of Alaska and by 86% on the discontinuous and continuous permafrost areas. So compared to previous studies in the literature that relied on OpenStreetMap, we actually doubled the estimated economic losses. So we found that building and road losses could actually cost Alaska anywhere between 37 billion to 51 billion under medium to high emission scenarios. And so obviously the next logical step is we want to do this on a Pan-Arctic scale. So that's it for my slides. Thanks a lot.
Thank you, Elias. Our next panelist is Bessie. Bessie, do you have some slides to share, or you want to discuss some specific point in terms of infrastructure mapping in the communities?
No, I don't have slides. I apologize. This is actually the first I'm seeing these slides. So, but I do have a couple of comments. This all looks really interesting and potentially very useful. So as you mentioned, I'm from Mekoryuk on Nunivak Island. So rural, very rural in the Bering Sea, population 200. So that's my viewpoint. But I find that data, as I think it was Elias mentioned, that data accessibility is one of the biggest barriers that we have here, and hoping that projects like this could help bridge that gap. And it's not so much that we don't have access. Clearly, we have basic internet, but the situation here is such that people like myself and 95% of the community have to access the internet on their phones. So visually is a difficult visual information or data intake is difficult because we are limited to the size of our phone screen. And another area that I think could be useful out of this information, the data, is improvement of communication between those with the data, researchers and such, to local decision makers. Not that they don't have the knowledge or the smarts to take in the information and use it that in a way that is beneficial to the local community. It's that the information needs to be filtered or expressed in a way that, in layman's terms, and taken into consideration, like I mentioned, that we just don't have the. It's really difficult to get the data electronically, and we don't have access to printers, so we can't blow it up and print them. So there's just a handful of people that have that capability. So that was one of the things that I wanted to add to all the information presented. Also, I think that in underserved communities like Mekoryuk, I think so I'm in Southwest Alaska. The information that I've seen looks focused on the north, more Arctic than we are, which is fine and fun. However, there should also be a way to bridge that gap between geographic locations. And I think that's about all that I'm able to add to the discussions right now. One of the things, if we or you all are able to implement any projects out here, it would be useful pretty immediately, along with all the other communities in the Yukon-Kuskokwim Delta, as we lose our tundra to permafrost. One of the situations here in Mekoryuk, for example, is the location of our cemetery. While it's mostly due to erosion, I am suspecting that permafrost is also a contributing factor to that. So I think that access to geological data or information for locals will be very, very useful in the case that we need to start moving infrastructure. So that's all I have.
Cool. Thank you, Bessie, for the feedback. Chandi and Elias, do you have any immediate response to the comments here?
I think when it's Bessie made really good points, right? So we think that we create really cool maps, right? And others can visualize on big screens, but it's not the case, right? So I was wondering, I tried Permafrost Discovery Gateway on my iPhone, but I don't know how things come out in the iPhone. Have you tried Wenwen?
No, I haven't.
Yeah, I think we should check that because the setup is a bit off. Maybe it's not optimized to mobile phones. That's something we should look into. Yeah. Elias, do you have any other thoughts?
Yeah, I mean, like Bessie had mentioned, the kind of the seems like there's an ongoing theme of data accessibility, and again that's kind of one of the objectives of this work that we're doing is trying to make an accessible centralized location. And obviously, it has to be done in a way that everybody can, in a way that's like equitable in terms of access. Because, there are lots of data sets floating around all over the place, and even there are lots of kind of different maps for different communities in Alaska, that I've kind of stumbled across in my research, and they're on the Alaska Geospatial data portal. But it's hard. It's hard for people to kind of pull all these different things together, and some people just don't have the time or maybe the capability to find the things that they need. So, and I think that's one of the broader goals of the Permafrost Discovery Gateway in general. Anyway, not just infrastructure data, all kinds of data. That's the end goal, is for us, of the Permafrost Discovery Gateways, to synthesize all these different kinds of data sets into a single place. So yeah, I think that's a pretty important theme, is data accessibility. Not just, yes, there is the idea of having complete data, but then there's also the point of making it accessible. So yeah, that's a good point there.
Thank you, Elias. Well, Bessie also mentioned a point that the map that you are showing seems to be a little bit north than her hometown. I wonder if you have any plan of extending your current mapping coverage.
Yeah, so I think for Alaska, within the state of Alaska, I think the original goal was, I correct me if I'm wrong, but I think that the total number of kind of like census designated places is, I think it's 355 in Alaska, and I try to map all of those, try to acquire imagery for all of those, but for various reasons, mostly data quality issues, some of those, there were some images that were just completely covered by clouds and snow and things like that. So I don't, yeah, I'm pretty sure that map covers the entire state, at least what you can see on the Permafrost Discovery Gateway. And you can also download it on the Arctic Data Center. I think it covers the entire state, but yeah, but no, it's true. I mean, a lot of we kind of have this cutoff of like, Chandi, what's the latitude of the Maxar imagery? It's like
60 north.
60 north. Yeah. So, whatever is below that gets cut off, but so that's kind of that would be like a logistical, that's kind of our logistical boundary, is like 60 north in terms of like satellite imagery, but I'm sure you can acquire aerial imagery. But I'll have to go look and see, Bessie, actually, what if what I'll have to go look and refresh my memory and see what things got left out. It's a good point though.
I also should mention that once data is accessible or more accessible than it already is, that it might be beneficial for the communities for outreach. And I know that would be a totally different project probably in itself, might be, but outreach and training if needed on the use of the software used to access the data. And just regarding the locations or the communities, even simple things like I didn't understand, and most of Alaskans, I'm going to tell you this, we don't speak 60 North, we speak Kotzebue, we speak Anchorage area, we speak Yukon Kuskokwim, you know, more of a physical location, I mean, community location by name. So that's, you know, that's just an example of the difference in knowledge intake of locals and terminology that would be and is another gap that should be filled once data is accessible and shared or put out to each community. I also should mention that I have heard through the grapevine that, and you may know this already, but I think the state, I'm not remembering at the moment which department or program is doing this, but the goal right now, and I think they've already started, is they are remapping all of Alaska. The geologic survey, I think it is. So whether or not the funding is still there to do that, given the economic situation, but just if you guys don't already know that, that's going on right now.
That's good to know. Thanks. Yeah, actually, I think there's also there was some company. There was also a company by the name of Ecopia AI, and I think they're based out of Canada. They actually did this same thing like 2 or 3 years back. But their focus, the reason they did it was a little bit different. I think it had to do with internet services, something like that. But anyway, that's besides the point. But yeah, no, anyway, in terms of the kind of the way, the terminology and things like that, that's a very that is a valid point. Yeah. And I think it's something that we are, and when I say we, I mean the Permafrost Discovery Gateway. I think that is something that is being like actively considered. So yeah, but it's a good point to bring up. Yeah.
Yeah, that's why it's a really good point. Once we have the data sets ready, that's something that the visualization team is doing, the PDG, the Discovery Gateway, some kind of aggregations, right, based on the community level. And we are trying to launch community-based mapping as well, rather than running these models across the Arctic. Okay, how about we focus on communities, map infrastructure and ice age polygons, then we can get the ice conditions and other features, because yes, we might be missing satellite images because of the cloud cover and other things, but there are very local imaging programs. Maybe NOAA did some coastal mapping, and other communities and community agencies did mapping, drone or area. There's a lot of data out there that are really valuable. And if we dig out from the Alaska Geodata portal and then do maps targeting these communities, and it's another layer of information getting to the users via Permafrost Discovery Gateway.
Yeah, those are good points. I do have one more. In the case that we're not able to, or any researchers are not able to do mapping in communities such as Mekoryuk or any other 200 communities. If there's a way, and maybe this could be, if there's a way to filter data, that sounds like a big task, to filter data for comparison to locations with the same geology base. So for example, Mekoryuk bedrock is basalt, and with a very, very thin, it's a really young island, basically. So it's a thin tundra cover, relatively. Um, as compared to our neighbors, 15 air minutes away, which is another way we speak instead of miles, is air minutes. They're I think it might be alluvial, and their sedimentary deposits is their base, is their first base before bedrock. I don't know how deep that is, but it's much different than here. So if I have always wondered for years, who can we compare our geology to, and if there's any work done there that they have learned from. So, I mean, that might be useful.
Well, thank you for the discussion. Do we have any questions from our general audience?
I have a question.
Go
I
ahead.
have many questions. Yeah, thank you so much for very insightful discussion and beautiful visualization. My question is, looks like you have some more southern borders for mapping in permafrost regions in the first slides. So it goes more to the south from 60-degree. Yeah, it's common. But the question is, you mentioned also roads. Do you plan to map them as well, or is it something?
Yeah, actually, so we did map roads along with the buildings, but I haven't processed that data set yet. So it's sitting there. It's sitting there on the hard drive. We have it, the mapped roads, but the thing with roads versus buildings, and I'm sure you know this, is that it's a lot harder to map roads compared to buildings. Just because roads, from remote sensing imagery, roads present themselves in so many different ways. And, you hear this distinction between formal roads and informal roads. And the informal roads are a lot harder to map because there's no clear boundaries between informal roads and then kind of the rest of the environment, It's a lot harder to make the distinction. With formal roads, there might be paved, there might be clear markings on the roads and things like that. That makes it a lot easier for, let's say, artificial intelligence to learn this is a road. But yes, we have mapped them, but what it's going to take is it will take probably a lot of manual inspection of the results to make sure that that the results are actually valid, and and to remove falsely detected instances and things like that. So yeah, hopefully that answers your question.
If I can add on.
Mhm.
So most of these the rural communities, have, I guess I misspoke. I'm not sure if most, but a lot of rural communities in Alaska have access to BIA, Bureau of Indian Affairs funding, specifically tribal transportation funding. And in those programs, they have an inventory of their roads, or they should. And those, and you're right. What you're saying is exactly right, because we're traditional lands. Not every road is, a gravel road or an actual legal road, so to speak. Some of it is subsistence access, just trails that have been used for millennia, that are not burrow, I guess, determined by a burrow or platted or whatever the terminology is. So yeah, we just keep that in mind. There's some data out there currently with traditional or local community mapping or identification.
Anyone have any other questions?
I see that we are approaching hour of our webinar, and yeah, probably people can stay longer. I have a lot of questions. I don't know if Elias and Chandi can stay longer than.
Yeah, I can stay.
Yeah, I just wanted to, if Vincent could share the last slide, and to mention that our next webinar will be on 5th of May. Everyone is welcome to join us, and then it will be focusing on bio-inspired adaptive infrastructure and infrastructure systems for Arctic communities, led by BLU. Also, in March, during the ASW, we had very productive craft workshop with focus on research priorities on infrastructure futures from community perspectives. And in the chat, I have put link to the notes. We are gathering more comments and notes in that document. Everyone is welcome to contribute. We plan to send it to ICARP4 by May 31, so you have almost 2 months to contribute. Those even who haven't attended the workshop in person. And also we have set up dates for our craft meetings in Anchorage on October 8th and in Bethel on October 9th, 11th. So we will be working with Ratsarar Native Council, with APU to organize it. We have some limited funding for early career scholars to apply to participate in these meetings. So yeah, you're welcome to send inquiries to me if you are interested. And yeah, please join our network if you are not part of it yet. And that's all what I have from announcement perspective.
Thank you, Vera. And thank you, everyone. I think we have a great discussion today to our panelists and all the audience. And I hope this is just a start of a lot of our productive collaborations and discussions down the road on using AI and other advanced technologies to support the Arctic communities. Yeah, thank you all.